Welcome back to our JEE Main series. Today we are cracking open a 3D geometry problem from the January 2026 shift. In the exam hall, time is money. If a question takes you 10 minutes to solve, you have lost the round even if you get the right answer. So let's read this problem. Let the line L pass through the point -3, 5, 2 and make equal angles with the positive coordinate axis. If the distance of L from the point -2, r, 1 is √14/3, then the sum of all possible values of r is which of the following option? Traditional textbooks will tell you to immediately write down the equation of line, set it equal to lambda, solve for a moving point. Today we are going to throw that entire process in the trash. Yes. We are going to solve this using pure vector geometry and shadows without ever writing down the equation of the line. So let's think sharp.
Hey thinkers, welcome back to Think Sharp Alley, where every turn leads to a smart solution.
We have the line L passing through the point -3, 5, 2 and look at the first constraint. Line makes equal angles with the positive coordinate axis. Standard methods makes you solve the 3D identity cos square alpha plus cos square beta plus cos square gamma equal to 1 just to find the direction cosines first. Don't waste your time. If a line makes equal angles, its direction cosines are identical. Because direction ratios are simply any three numbers proportional to those cosines, equal angles automatically mean equal direction ratios. So we can instantly write down our line's direction vector as the simplest integers possible. Let's represent the direction vector by b, 1, 1, 1, where L is our line. Now normally you would use this to write a Cartesian line equation, but we don't need it. Let's look at the pure vector geometry instead. And let's visualize what's actually happening in space. So we have a known point on the line, which is A, -3, 5, 2, and our external target point Q, which is -2, r, 1. Let us join A and Q, and if we drop a perpendicular from Q to the line at the point M, we get a perfect right angle triangle AMQ, where MQ is already given to be √14/3. So to solve for R, our game plan is incredibly simple. We will first find the length of the hypotenuse, which is the magnitude of the vector AQ. Then find the length of the base AM, which is just the scalar projection, that is the shadow of vector AQ onto our direction vector B. And then link them together using Pythagoras Theorem. So let's do step 1. Let's build our hypotenuse vector AQ, that is Q minus A. So here we had -2 minus 3, that becomes -2 plus 3. Then we have R -5, and the third component is 1 minus 2. That gives me 1, R -5, -1. Now the magnitude of AQ is square root of the sum of square of each component, so which simplifies to 2 plus r -5 whole square. Now for step 2, we find the base AM. Instead of finding the exact 3D coordinates of point M, we just find the length of its shadow using scalar projection formula. We dot vector AQ with our direction vector B and divide by the magnitude of vector B. So let's do the dot product first, AQ dot B. So we multiply component wise. So since B is 1, 1, 1, multiplication is simple. So we get this, and on simplifying we have just r -5. Let's find out the magnitude of our direction vector B, which is square root of 1 square plus 1 square plus 1 square. Remember, square root of sum of the squares of the components, that gives me √3. So the length of our base AM is exactly r -5/√3. Notice something mind-blowing here. We completed the entire setup without ever writing down the equation of the line. We completely bypassed an entire traditional textbook setup. Now step 3. Let's finish the problem using Pythagoras Theorem in our right triangle QMA, which is QM square plus AM square equal to AQ square. So let's plug everything in and we get this. Taking square of square root removes the square root, so we get this. Do not expand that r minus 5 whole square bracket into a messy quadratic. Treat it as a single variable block. To get rid of the fractions instantly, you can multiply the entire equation by 3. Here I have just separated the constant and r minus 5 whole square part and simplified it to look something like this. So the denominator 3 gets cancelled and 8 and 2 also gets cancelled to give me r minus 5 whole square equal to 4. Now let's take the square root on both sides. So we have r minus 5 as plus minus 2. That means it splits into two beautiful clean equation. One r minus 5 equal to plus 2. Another time r minus 5 equal to minus 2. That gives me r is equal to 7 or 3. Now the question asks for the sum of all possible values of r. So we just add them up. So we get 7 plus 3, which is equal to 10. So for this question, option A is our final answer, absolute lock. By slicing out the line equation entirely and attacking this with pure vector shadows, we saved massive calculation time and protected ourselves from silly algebraic mistakes. If you want to keep learning how to look right through JEE math questions and find the fastest shortcut, make sure to hit that subscribe button. Drop a comment below if this pure vector approach opened your eyes, and I'll see you in our next problem solving lab. Think sharp, study smart, and keep crushing it.